Donnie, what are you doing?
Ladies and gentlemen, this is my brother Donnie. I'm putting down Allen wrenches back together.
Okay, folks. We have been working on this CNC machine that we picked up. It had been basically crashed. They bent one of the rails. Is it rail? What do they call it? Rack. One of the racks. And it was disassembled whenever we got it. Donnie went out of state and picked it up. He did a whole video of that.
He tore my truck up doing it. If y'all watch the channel, you see my red truck went down right afterward.
That's a good point. Yeah, it could have been. So he went and picked this up out of state and drug it back here. We've been messing with it because we've got an older, a smaller, well, I don't know. We have another CNC table that we use pretty regularly to cut melamine with and plywood, but it's a little slower and less powerful than we need. So we're trying to build like a heavy duty super duper super soaker version. And so we went and picked this thing up. We don't know anything about it. We can't figure out even who made it. And it came out, we believe it was manufactured around 1999 by some of the electronics that was on it. It was missing a bunch of the gearing and things like that, so we've been slowly putting that back together. So on the previous videos, you saw that. If you didn't watch that, go back and check. We've got a playlist on this. You can watch the whole playlist if you want. But when last we left you, we think, finished up kind of the mechanical parts of it. So we figured out the pulleys. I can illustrate it better up here. We figured out the pulleys that we needed. We ordered a motor that we're going to try out. We got everything mounted. We got the gearing, the pinion gears that we believe that we need. We put new bearings in it, all that stuff. And we believe we've got it all back together mechanically. But we haven't, to the best of our abilities. But we haven't done one thing electrically with it yet. So this video, we're going to show you some of that as we keep inching a little forward. So what our goal is we'd like to get to the point where we can test this motor. So this is an Oriental Motors, a Japanese company. I can't show you the part number because it's upside down. It was on the previous videos. We'll talk about it whenever I find it. I don't even think it's on that box over there. Anyway, we're trying to test this motor, but to do that, you got to have an electrical system that can run the whole thing. So what we're planning on doing is we have an enclosure that we're going to mount right here under the table. And the thing originally, it looks like, had this big Frankenstein on-off switch here, which we like. And so we're going to hook up to this to run our electrical box. Look at that big bad boy. What do you think, Donnie?
It looks like Big Papa.
Big Papa. So that's where our power is going to come in. It comes out here. Or actually, that's where it's coming in to that. And then we're going to have it come out of there over to our box that is eventually going to mount here. So let me show you the enclosure that we're using. So Donnie was able to snag these bad boys. This is a big old square D enclosure that has never been used. He got two of them actually. Never been used, hasn't had any knockouts removed from it. And it's just a big, well, I'll show you here in a second. But it's just a big metal enclosure that's completely empty inside with nothing in it. And he went and picked it up on the Facebook. Do you think they know about the Facebook?
Probably. Man, that thing's heavy.
Gonna bust a gut.
Somebody's got it screwed in.
Yep, so the door don't fly open. Look at this beautiful thing. Now, is that a nice piece of stuff or what? Look at that. Look at that. Where was it made, Donnie?
This one? It was probably made...
Hold on a second. We got it right here. We're upside down, but they'll be all right. It's an enclosure assembled in Mexico. That's cool. I like Mexico.
Me like Mexico too, boy.
Nothing wrong with Mexico. All right, so yeah, it's got some stuff. I don't know. I think maybe there may have been a plate in it.
I think there was a big plate in here that somebody took them out.
Somebody took out, but then where's the ingress?
Like,
the wire didn't come in.
no, I think they were
Something
probably rebuilding one.
Something don't add up.
They took the guts out of this one, put it in another.
I think it's new because none of the knockouts have been knocked out.
Absolutely. It's
What do you
new,
think?
but somebody took the guts out and put it in something else.
Yeah, so maybe it came with some more stuff. So this is what we're using. We've already begun using it, but you know, with one exactly like this, we have two. Now we got to figure out what to do with this one. Maybe if we run out of room in the other cabinet, we can do it.
I thought we was gonna make a gerbil cage out of it.
Gerbil cage. Okay. Yeah, we can. We could make a gerbil cage. Yeah, we can do that. Talking about a freaking gerbil. What the? I think he's lost his mind. Hey, here he comes. So this is the cage that we're building. You get a quick little look at some of the stuff that's going on. Now, folks, we're not trying to show you how to do it.
Never.
We're showing you how we're doing it. Now, you may disagree vehemently. You may say, oh, these rednecks are idiots. Oh, they're going to burn the building down. But come on, people. Now, should we explain the flash dance lighting for them?
Yeah, we can.
China.
That's the problem.
We've got lights that we've hung up in our warehouse here. They're hanging up for maybe 40 hours that they've been on, something like that.
These up here probably not even that.
Flash dance. Flash dance. There's another. I'm so excited and I just can't hide it. There's one down there doing the same thing. So 4 out of like 15 of them or whatever, 20 of them are flickering because what's the problem?
China, and one's burned all the way out.
China. Yeah, one burnt completely out. China. So when we're building this thing, we're trying to use as little of China as possible. And really, you know, I don't want to argue with anybody about it. I'm just saying it's low quality crap. And it's pretty much only China. Like if it's Japanese, it's high quality stuff. If it's Mexico, I don't have any problem with stuff made in Mexico. If it's European, it's good quality stuff. If it's American, it's good quality stuff. We're getting a lot of crap from China. So that's just how it is. So this is what we're trying to build, and we're trying to use stuff that's not made in China. We've been pretty successful so far with it. On the table, the only thing that's from China that we've bought are the pulleys, the XL15 pulleys. I had to do China. But maybe we'll find some American ones and I'll swap them out. So here's our enclosure. It's going to mount where this door hinges up. So this is the top and that's the bottom. So we'll show you what we've done so far. I guess we should show them the power coming in. So we got this big
behemoth.
This big hank of cord coming in. I don't know what size that is. It's pretty big.
Pretty big.
That's like big wire. We're going to run about 15 amps through it.
It's big.
Yeah, so it's going to have about a 15 amp load, we think. I'm not an electrician, but we're figuring it out. And then we have some of these cool vintage buttons on it.
Vintage.
Now, some people aren't going to like this, but oh well. So this one, now remember it's got the big Frankenstein switch. Okay, so this whole box is going to be dead if that switch is on.
Yep.
Okay, so power comes in if the Frankenstein switch is not off. If it's on, though, this light will be red, Donnie.
Okay.
See, Donnie's going to be our operator.
I'm the operator.
So we're teaching him as if I know anything to teach. But so this light will be on if there's power on the box.
What happens when that light bulb burns out?
Then you're in big trouble.
We'll have to replace it.
Yeah,
Keep me smacked.
yeah. Watch your light bulb.
Okay.
So there's this. We could wire all of the voltage through the bulb, and then if the bulb burns out, it kills everything.
Yeah, we'll do that. Okay.
Okay, so there's this. And I bought these on eBay. So the reason it says hot winding is because that's the plate that they sent with it.
The winding is going to be hot.
Yeah, so it makes sense, really. So I put that plate on there. Now these things are cool. You can take the little cap off and get to the bulb.
So I told you we were going to change the bulb.
They got all kinds of different little, they're just neat. Neat.
Can I put a little emblem of my brother Donnie in the middle?
Yeah, you could, if somebody make us one and send it to us. Let's see, I've got another one here. I can show you what these look like. So this is what we're using. Now these are all old. They are made by, I don't remember who they're made by, Donnie. But that's it's a 9001 Series G. I got another one here, I think, too. Look at this one. You're going to love this. Look at that bad boy. I'll show you the button thing here in a minute. So this is square D as well, I guess. Okay. So it's just old school square D stuff. This particular one, even though it has the button, it doesn't have the attachment on the bottom, so it's just that you hook up the light there. I'm thinking there may be a transformer in here. I might be screwing up using the wrong bulb in it. I'm gonna have to figure that out. Okay, so it has a push button, and see it has like a different collar on it to protect the button so you don't accidentally hit it. But then underneath it, there is a switch. Here's another one that's white. I've been hoarding these things on eBay. They're cheap too. They're like $10. Okay, so that's what that is. Okay, and then we're trying to hook it up where you hit the green button to start it.
Green button started.
So by starting it, I mean starting the power supply, voltage to the motors, all of that, okay? Red button is your safety stop, E-stop. There's gonna be another one at the other end of the table. Bam, 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 okay? But you also have the big Frankenstein switch too, okay? So in case there's an emergency, you can smash that thing and it'll kill everything. Not everything, but it'll kill the power supply that's basically running everything. Okay, so now there's a big rat's nest of wires in here, people. We're like 25% through, okay? So here's the bottom of the switches. So since this one's just a light, you just got the wires to it. I may have this wired wrong, though. I'm gonna have to look into it, because if there's a transformer in there, I might have the wrong bulb in it or something. We'll figure it out, okay? I need to see what voltage the transformer needs and what voltage it puts out and all that. Okay, so this is the main power light. This is our start, this is our stop, okay? So if you see on these, they have this little attachment here, which can mount to any of them. So you can take this off and mount it over here, and make it this one's actually just a light, but a lot of the ones you can make a button or a light, just depending on how they're made. It's all kind of where you can change stuff around. So we've got a normally closed switch and there's a normally open switch. So when you press the button, it connects these together. Now we did this a couple weeks ago, so I can't even remember exactly how I did it, but you've got the power coming in, it's running through a breaker, and then we've got it powering up is it 24 volt? Yeah, 24 volt power supply, okay? So basically this has power if the Frankenstein switch is on. This is running through a contactor, which is used, the coil's down here. It's running through the switch into the contactor to pull the contactor in whenever you hit the start button. And then you've got your 120 that will feed the power supply running through here. So basically, if you hit the stop button, it pulls this contactor back out. And now you've still got power on the 24 volt power supply, but you don't have power on everything else, okay? Now, my buddy Matt was telling me that the contactor might fuse together and cause all kinds of problems. But, you know, I've got circuit breakers on stuff. It's kind of, eventually you're going to get to the point where something's going to, you know, we've got line coming in with a breaker on it. We've got the Frankenstein switch. There's a breaker in that box. You get in here, it runs through a circuit breaker. You're kind of, if you've got a circuit breaker on every little step of it, eventually you're going to get to a place where there's something that, yeah, it can weld together if it wants to, I guess. So, all right, so then the 120 would be running through here and run off to run the power supply. Lift that cord up there, Donnie. We'll show them the power supply. So the power supply is this big old sucker. I can't remember the name of the company that made that. That's actually, oh, by the way, Eaton, I don't know where it was made, but it's not China. The contactor, made in the USA. These little distribution blocks are probably made in China. Power supply, made in Japan. You know, I think that stuff's important for people, if you can help it. Where is this made? Made in Switzerland. Boy, that's high quality. Allen Bradley, made in Switzerland. This is a backup for our backup. The wire's probably all made in China. Okay, so the power supply is going to feed over to, well, it's going to feed over to our motor drivers. So they're Gecko stepper motor drivers. We only have one so far because we're trying to test it to see if it's going to work, if we know what we're doing. If we made a big mistake, we'd rather make it with one set than with 4 sets. Okay, and then we're feeding it into it's being controlled from the computer into a USB smooth stepper. What do you know about them smooth steppers, Donnie?
I don't know much about them.
We're feeding it into our smooth stepper, and then there's this little breakout board that actually sends the signals from the smooth stepper over into the drives. Okay, and then we've got on the edge over here, we're attaching this. We might have to put some silicone on there if we're trying to make it airtight, I guess. We're attaching this with just a big cable clamp coming in. And over there, we have these two little interesting little things that we bought on eBay. Probably made in China, but it'll be all right. Where basically one of them is where we're going to be able to connect our cables to our motors. And then one of them is where we're going to be able to connect our USB line from the computer into the cabinet. Those are pretty cool little setups. That big old heat sink under the Gecko drive is from Gecko. Gecko's made in the USA, by the way. And the power supply is made in the USA. The smooth stepper, I think it's made somewhere reputable. That board, maybe not. But we're just, it's not, like I said, the wire and stuff's probably from China. It's not important that everything isn't from China. I'm just saying if you've got the option and you can do it, do it. The motor, for instance, we got one made in Japan. We could, oh, it's made in Vietnam. Okay, there we go. That's fine. The motor, you can get U.S. made motors. They're very expensive though. So for what we're doing, we weren't in a position that we could afford to do that right now. So we got kind of a big mess going on here, but we're working through it. So we're trying to get this to run the motor, test drive it, and see if we can get the thing to move at all. So we need to fabricate a line from the connector to the motor for testing purposes for now. We need to connect our power supply to the Gecko. We need to connect our computer to the smooth stepper. We need to connect the smooth stepper to the breakout board. And we need to connect the breakout board to the Gecko. What do you think, Donnie?
Lost.
This is a 5-volt power supply to run the smooth stepper. Now, it is not on the emergency stop because they basically don't want, basically that thing can tell the computer, basically they want a signal, they want this to stay live while if the machine crashes. So if you hit the E-stop, they don't want it to kill the smooth stepper as well. So we're still learning and figuring it out as we go, people. But that's what we're looking at. So we got a big mess here. We got to straighten up a little bit, and then hopefully we can test drive that motor. If we can, then we still got to set it up with Mach 3 too. That'll be the fun part. Here are the little cable things. Okay, and we've got it hooked to the bottom one. Okay, so I think what I'm going to do, I'm trying to figure out how long to make my cable. I don't need it that long, but I'd hate to. We're just going to temporarily connect it to our motor. Well, hell, I guess I could. Well, no, we'll have so much voltage drop that wouldn't be good. So I got to make a cable. We're going to tie it to it, and then we've got to finish up the stuff in here, and then to get the computer controlling it. But I like these little things. Very cool.
What are you doing?
Yeah, we're getting there. Okay. Boy, this is some highly crazy stuff. Boy, they're gonna love this crap. Boy, we're doing this so wrong. They're gonna
love us.
Whew, they're gonna tell us all the ways we're doing it wrong. Okay, so the power comes in on this big old thing. The neutral comes to this neutral distribution bar. The hot comes through the breaker and then into the hot distribution bar. Okay, then the hot and the neutral come out of here and power up a 24-volt power supply, Donnie.
24-volt power supply.
Because the contactor needs a 24-volt to contact.
24 to contact.
So that's hot. It also powers up a 5-volt power supply.
5-volt.
Because the smooth stepper needs 5 volts. Now the smooth stepper, you see this little LED, it looks like it's smoothly stepping.
Yep.
It's actually called that, a smooth stepper.
Well, it must be stepping smooth.
Yep, because it controls the stepper motors from the computer. Okay, it is plugged in over here, but we do not have the computer plugged in yet. Okay, and then the power distribution block. There's a whole bunch of this 24-volt stuff. So basically the 24-volt that comes out of here is coming over to this distribution. And all the cables, we're going to tidy them up later. Okay, we're just getting it all, figuring out how we want it laid out and all that first. And figuring out if our idea works or if we got to add stuff. I'm sure people will have plenty to tell us to add. The 24 comes over here, so this is ground and 24. The ground is tied into the ground coming from the wall through our big cable. Okay, so this is 24. So the 24 comes through the switch. No, the 24 powers the power light, but it also comes through the switch to power the transformer over here. Now here's the problem with the lights. I think those lights have a transformer in them. I didn't even think about that because usually I'm using pinball machines, jukeboxes, arcade games and stuff, and so you just plug right into the light. So I've got 24 volts powering that, but it says right on the side 12 to 24 volt. So I was thinking, oh, that's the bulb they have in it, but no, there's probably a transformer that wants 12 volts, and then on the other side it powers whatever that bulb is, 755, I think it says, a 755 bulb. We still got to do a bunch of research on that. And then these two are the same way, but these say 110 on them, where I'm running 24 to them too through all of my little contraptions here. But I think they got a transformer in them that wants 120. That's why they're not lighting up. Didn't one light up for a minute though?
Yes, if you wiggle the bulb, mess with it.
Did it? Yeah. So I still got to look into that. I might have to change all of them out with a different transformer. If it has a transformer in it, I don't know. I'm gonna have to look into that. Okay, but this is the thought behind it. There is a contactor over here that's normally closed, or a contact on the contactor that's normally closed. So it lights up that red one. Okay, and then there's one here that's normally open. It lights up the green one. So I don't know if we should do it that way. We might want to reverse that. But anyway, I'm still thinking about it. So basically, when you hit this switch, the start one, it connects power, the 24 volt, to the, oh, you know what? That's not the light. Anyway, we'll get to it. It connects power to the coil on the contactor and pulls the contactor in. When the contactor pulls in, it connects this wire on itself and holds itself in. So when you let go of the button, that's no longer providing power to the coil, but now this is providing power to the coil. So it stays down when you hit that button. Okay? When that pulls in, it turns on the 120, which is coming from the distribution blocks. It runs over to here to our power supply. Now we'll probably put a breaker in the middle of that to our power supply. So the power supply is I told you I'd show you what it was. Oh, if I can get to it. It is a Antec, which is made in New Jersey, I believe. So it's an Antec, okay? And it's an 80 volt times 2. This is a 5 volt, which I was going to use to run the smooth stepper, but if I did that, if I killed power to the power supply, it would also kill power to the smooth stepper. So I got the separate 5 volt power supply so that it wouldn't go off whenever we kill the contactor. And there's a couple reasons for that from what I understand. Okay, so when the contactor pulls in, it should turn on a light on the, I can't decide if I should make it where the green light comes on whenever it's running or the red light comes on whenever it's running. So you can see the red light to hit it and turn the game off, turn the machine off. I don't know, we'll figure that out. Okay, so we're still thinking about that. So anyway, that's what we got going on, okay? So whenever you first turn it on, you've got power to your light, you've got power to your smooth stepper. If I hit the start button, it should power up the power supply. Without the power supply on, all of the motors should be dead. It's not an 80 volt times 2. What am I thinking? It's a... Anyway, you can run 4 motors off of it. It's an 80 volt power supply is basically what it is. So we can run 80 volts into our Gecko, which is like right at the limit. That's about as much as they want in that Gecko. The Geckos apparently are pretty good stuff. Okay, so if we hit the button, we should see the contactor pull in. And that should turn on our power supply. So, Donnie, hit the button. The light is on, the main power one.
Ready?
Yep. See any fire?
No fire.
Okay. Donnie, come check. I only have one hand. Come check the power supply. Now the power supply, see right here? So this is all powered. See these little lugs here?
Yep.
By the way, people, I'm 6 inches away from it. Just looks like I'm touching it. But they are alive. So you see the negatives and the positives?
Yep.
Okay, you're going to check negative and positive.
Okay. Negative and positive.
Yep.
On any of them?
Well, we're going to do each one. 81 volts. Yeah, baby. Okay, move over to the other one.
This one?
Yep.
Negative there, positive there.
81 volts. Okay, check out the little one. We're not going to use it, but the little 5 volt one.
Well, I can't see the positive. Yeah, I can.
Don't short it to the frame. That would be explosive. 4.99. That's close enough. Okay, well, that is turning on the power supply. Okay, now we need to test the stop button.
Okay, let me go hit it.
So if you hit the stop button, that should stop it. It went back out. Okay.
I gotta check them again.
Yeah, let's check just to see if it's dead like it should be. I would assume it is, but you know what happens when you assume. Boom, that's what happens when you assume. Look at that. There's a residual voltage. But I think what's going on is the caps are draining. And if you had a motor or something with some kind of draw on it, it would have sucked that down real quick. So y'all tell me down below if I'm correct in that assumption. There is no AC power going into here anymore. Let's prove that. And again, this is temporary. Temporary, people. What's it say, Donnie?
0, 0, 1.
Yeah, so there's
0, 0, 0.
There's no AC going into it. So that voltage that I'm reading there is just what's left of what's in those caps. And with a motor running, those motors would stop pretty quick. It would run out of that. Okay, but if you look, our smooth stepper is still on. because it has its own 5-volt power supply. So I think that's pretty good. Okay, so I need to get I had a cable for this, but I don't understand why they did this like this. The smooth stepper can control, I think it's 3 separate. It's basically, Mach 3 uses a parallel port. The smooth stepper is allowing you to use a network cable, an Ethernet cable to connect to the computer that's running Mach 3, and then it's kind of simulating parallel ports. So this little board is what you connect all your inputs and outputs to, but the problem is it's got a male connector, and this thing has a male connector. I don't know why they did that, because if you look at a parallel cable for like a printer, also male connectors. So I don't have a double-ended female connector to connect from there to there. I don't know why they would do it like that. It's kind of weird. It may just be, I think I got this used, so it may just be there's a different version, and you can get whatever connector you want. I don't know, or maybe you can get a different board with a different connector. But we'll have to get a female-to-female adapter. But I think we've got the bare bones of a system. This area over here, we're going to put our spindle power supply in it. But I've heard those can introduce noise. But we'll see. I've heard other people say, it's not that big of a problem. So we'll see. So it'll be over here. Oh, and we're also going to put in fans and a filter so that we can cycle air through it and keep it cool. So that's our plans. Let us know down below what you think so far. Tell us what we're doing wrong, and we may fix that, or we may just say, not that big of a deal.
You better hurry up.
You better hurry up too, because we're getting on it. But we got to get the adapter, and then I think we'll be ready to basically, we've got it where the power supply is working, we've got the smooth stepper powering on, we've got the contactor working, the start and stop buttons are working. We're pretty close. We gotta do the computer stuff next time. So hopefully y'all found some of that enjoyable. I gotta put some spade connectors on a lot of this and clean it up, make it look a little better. What do you think, Donnie?
I think this is totally out of my ball game, but I'm pushing buttons with this one finger. Is there anything I can't touch?
Yeah, all of that has a lot of juice on it. See, we're gonna have the top shut, where we don't mess with any of this.
Well, I don't know. I think I can fix it. But anyway, give me a thumbs up for filming it, because I filmed it all. Subscribe to the channel if you hadn't already, and we'll catch you on the next one.
All right, folks, hope you enjoyed it.